All right, guys, so what we're starting today is Chapter 2. We're moving on to Chapter 2. So any of the homework assignments you have not gotten done and turned in from Chapter 1 are due at the end of the day Friday, after which they will become zeros. So get any of the assignments that you have from Chapter 1 that have not been turned in and graded, turned in by the end of the day Friday. So we're moving on to Chapter 2. Chapter 2 is going to be specifically revolving around quadratics. That's going to be the main topic of this chapter. So unlike the last few chapters where we've kind of jumped around and done a lot of different things, this chapter is mainly going to focus on quadratics. Now, our quadratic function in vertex form comes in this form here. F of x, or g of x, equals a x minus h squared plus k, or y equals a times x minus h squared plus k. Either one of these here, this is the version of the equation we call vertex form. And there's a reason for it, and we'll delve more into it, especially when we talk about the different versions or different ways we write a quadratic equation. But this here, vertex form, is helpful for talking about transformations. And this one here has three main transformations, or three different things we're applying to it. Now the h we're used to. Our h is our left and right. This constant h is going to move the quadratic equation to the left or right, and it's always the opposite of what we think. So if we had x minus 2, it's actually moving it to the right 2, not left 2. If it was x plus 3, it's moving it to the left 3, not right 3. Now the value of k is our up or down, how far we're moving the function up or down. Now our up and down is exactly what we think. If it's plus 2, it's moving it up 2. If it's minus 7, it's moving it down 7. Our k is our up and down. Now a has a few things, because if the number or term in a spot is negative, we're talking about a reflection across the x-axis. If the number in a is something other than 1, it's vertical stretch or shrink. Because if a is greater than 1, it's a vertical stretch. If a is between 0 and 1, it's a vertical shrink. And there was one other spot. There is a value that can go in front of the x inside the parentheses. That is our horizontal stretch and shrink and reflection across the y-axis. But before we do get completely into all that, the main steps or things we're looking at is this here. Our horizontal and vertical translation. Our h, if a number is in the spot where h is, it's telling us that the function is moving left or right. And it's always the opposite of what we think. Because if we have x plus 3 inside the parentheses, it's moving left. It's moving left 3. If it's x minus 3, it's moving right 3. Our value of k is how far the graph shifts up or down. And our up and down movement is exactly what we think. So if it's plus 3 on the outside of the parentheses, it's up 3. If it's minus 7 outside the parentheses, it's down 7. So if we look at this first one here, describe the transformation of f of x equals x squared represented by g of x equals x plus 4 squared minus 1. Then graph the function. So really what we're saying is how far or where did the graph move? Up, down, left, right. And we have two things. We have two things that are taking place. We have the plus 4 inside the parentheses and the minus 1 outside. When we have a number being added or subtracted from x inside the parentheses, it's moving it left or right. How far would this one be moving to the left or to the right? It would indeed be moving left 4. The 4 tells us how far we're moving, so it's moving 4. Since it's x plus 4, it's moving left 4, because inside the parentheses, it's the opposite of what we think. Since it's plus 4, we're moving left 4. If it had been minus 4, we'd been moving right 4. Questions on this here? The next part of this is the minus 1. Since it's being subtracted outside the parentheses, it's moving it up or down. How far are we moving? Down 1. Our up and down is exactly what it looks like. So since it's minus 1, it's going down 1. If it had been plus 1, it would be going up 1. Questions on this here? Now, if we were to graph this, and again, I'm not going to have you graph it on the homework, but it's mainly getting a visual of what the graph would look like, how it would change. Here, the graph that they gave us on the board, this is the parent function, the f of x equals x squared. And what we said is every point on this graph is moving left 4 and down 1. So this point here would go left 4 and then down 1. This point here would go left 4, down 1. This point here would go left 4, down 1. And our new graph would look something like this. Here we just move the whole graph left 4 and down 1. Questions on this here? We feel good with this here so far. Let's look at this one here. So we want to describe the function, the transformation, how we got from x squared to x minus 3 squared. Well, if we look at this here, x minus 3 squared, the only thing we have is the minus 3 inside the parentheses, yes? Which means we're moving to the left or to the we would go right 3. Because left and right is the opposite of what we think. Since it's minus 3, we could normally think left 3, but it's actually right 3. So that's the only movement that we have. And really, all of this entire graph is going to shift to the right 3 spots. So this point here, 0, 0. It's not 3, 0. 1, 1 is now 4, 1. Negative 1, 1. Really, all of these points are just shifting over 3 spots. 1, 2, 3. There's our new graph. So if we were to graph it, all we're doing is shifting it over 3. Questions on this here? Are you ready for the next one? Yes. Let's look at this one here. X minus 2 squared minus 2. So we do have 2 different operations. We have the minus 2 from x inside the parentheses and the minus 2 outside. Let's do inside first. So x minus 2 inside the parentheses tells us it's moving to the left or right, and it would be to the right how far? 2. Right, 2. The minus 2 outside is telling us it's either moving up or down. Where are we going? So the minus 2 outside would be down 2. And that's it. Questions on this here? Now again, on the homework, I'm not going to make you graph these. We're just describing the transformations. Now we did these in chapter 1, some of this here, but we didn't actually apply any of them. That's why they saved them for this one here. So we good with this here. Let's look at this one here. We have g of x equals x plus 5 squared plus 1. Yeah, so the x plus 5, the plus 5 inside the parentheses. Let's tell us that we're moving to the left 5, and the plus 1 on the outside is up 1. because left and right is the opposite of what we think. So plus is actually left, minus to the right, so left 5. Our plus 1 on the outside does indeed move us up 1, because those are nice. They're exactly what we think. Our next one here, h of x equals x minus 1 plus 2, or x minus 1 squared plus 2. So our x minus 1, that minus 1 inside would be right 1. And the plus 2 on the outside would indeed be up 2. And that is it. Questions on this here?
Please show me it stays this simple.
I have a question.
Yes.
Why is negative like 1 minus?
So here, x minus 1. Well, the general form, so x minus 1 squared
Oh,
is x minus h in the general form squared. Yes? So here, if we match these two up, x's are the same, minuses are the same. So the value of h is 1. Yes? And positive 1, specifically. Well, positive direction is to the right. So it'd be right. Now, if we said in the previous one we had left 5, yes? Inside the parentheses, we have x plus 5 squared. In the general form, it's x minus h. What that means for us is really, we do have x plus 5 here. What it's actually telling us is that it's x minus negative 5 squared. Because a negative minus, if we minus a negative, it makes a positive. So here, the value of h is not positive 5, it's actually negative 5. So it would be left 5. So one of the tricks we've seen, or kind of we've gone over to keep track of left and right, is the opposite of what we think. So since we have plus, we're going left. If it's minus, it's going right. And it's mainly because of that x minus h. That minus h is causing the value of h to flip, giving us that flip of direction. Does that make sense? Questions on this so far? Reflection in the x and y axis. If the negative is outside the parentheses, or there are no parentheses, it's a reflection across the x. If the negative is inside the parentheses, it's across the y-axis. Inside parentheses, negative inside parentheses is across the y-axis. Outside parentheses is across the x. So we could say over here, if a is negative, reflection across the x-axis. If b is negative, or the negative is in front of the x inside the parentheses, it's a reflection across the y-axis. The other two things we have are horizontal stretch and shrink, and vertical stretch and shrink. So it's a vertical stretch if the value of a, the number being multiplied, is outside the parentheses and greater than 1. It's a vertical shrink if the number being multiplied outside the parentheses is between 0 and 1. Horizontal stretch or shrink. So horizontal stretch, if b is greater than 1, and horizontal shrink if 0 is less than b is less than 1. Have to flip. And we'll see that here in a second. Now, seeing these and seeing these applied is going to be a big difference. Let's actually look at some examples with these here. Now, if we look at this first example here, g of x equals negative 1/2 x squared. The negative and the 1/2, are they inside parentheses or outside? Are there any parentheses? No, so they're automatically outside. If there are no parentheses written, it's outside. So here there are no parentheses, so the negative and the 1/2 are both outside the parentheses. Now, there are two things here. We have the negative and the 1/2. They are split, they are separate. If we have a negative sign, negative being multiplied by x, either in front of parentheses or inside parentheses, the negative is reflection. So this negative, purely the negative, is talking about a reflection. Across the x-axis. If a negative is being multiplied by a variable outside the parentheses, it's across the x-axis. If it's being multiplied by our x inside the parentheses, it's across the y. That is all the negative is. The negative in front of this x is just talking about the reflection. Questions about the negative and the 1/2, or negative so far with the 1/2? Are we good with the negative? Yes? The 1/2, not the negative, just the 1/2 is talking about a vertical stretch or shrink. If it's inside the parentheses, it's a horizontal stretch or shrink. So here, since the 1/2 is outside, we're talking about vertical stretch or shrink of 1/2. Yes, vertical shrink of 1/2. If it's between 0 and 1, it's a shrink. If it's greater than 1, it's a stretch. So the negative 1/2 x squared, the negative would be a reflection across the x-axis. The 1/2 is our vertical shrink of 1/2. And that's it. So again, that negative and 1/2 are not one transformation. They're two separate transformations. Questions on this here? Now let's look at this one here. Again, we do have two transformations. Is there a negative in front of our parentheses? No. So that means there is no reflection across the x-axis. We're not even going to list it. Is there a negative in front of the x inside the parentheses? No. So there is no reflection across the y-axis. There is no reflection at all. We will not list it. But we do have a 2 in front of our x inside the parentheses being multiplied. And we have a +1. Let's do the nice one first. The +1 would do what? Move it up 1. The 2 is horizontal stretch or shrink, yes? Now again, when we talked about this in chapter 1, applying the horizontal stretch or shrink, we had to flip it, yes? Flip it going in. So if they gave us a horizontal shrink of 1/2, we put it in as 2. We have to take this value for the horizontal stretch, and flip it. So the b value, that value that's going in there is not 2, it is actually 1/2. Which means that this is a horizontal shrink of 1/2. Before you start looking at horizontal stretch or shrink, take whatever numbers being multiplied by x inside the parentheses, flip it first. take it and flip it first, then look at it in terms of stretch or shrink. So if we take that 2 and flip it, it goes from 2 to 1/2. Okay. 1/2 is between 0 and 1, so it's a shrink. If we took it and flipped it and got a whole number, so just 3, or a number greater than 1, then it would be a stretch. Does this make sense? Now, if we looked at the graph, pull up the graphing calculator, y equals, let's clear all that out, x squared. We have this here, y equals, parentheses 2x squared. We'll do plus 1. So we said it's a horizontal shrink by a factor of 1/2. Horizontal, left, right. If it shrinks, it means it's increasing slower. It's kind of squished more along the x-axis. Let's see if it does show us that. Well, yes. It's skinnier than the one in blue, yes? Better yet, I'm going to remove the plus 1. And as we can see here, we did shrink it along the x-axis, so that is indeed a horizontal shrink of 1/2. Do we see that there? So with horizontal stretch or shrink, before you try to figure out which one it is, take that value and flip it. Take that value and flip it, so 2 becomes 1/2. 1/2 would become 2. And that's it there. Questions on this here? Okay. G of x equals negative 3x squared. How many transformations do we have? 2. We have the negative being multiplied by the x and the 3. The negative, whenever we're multiplying by a negative with our x, it's a reflection across the x-axis or the y-axis. Yes. Now this one here would be across the x-axis. And the main reason it is across the x-axis is because that negative is outside the parentheses. If the negative was inside the parentheses, it would be across the y-axis. Now the other thing we have is the 3, yes? Is the 3 inside parentheses or outside? There's no parentheses, so it's automatically outside. Since it's outside parentheses, being multiplied by the x, it is a vertical stretch or shrink. And it would be stretch. Vertical stretch of 3. The 3 is telling us if it's a vertical stretch or shrink. The negative is purely with the reflection. So even though it is negative 3x squared, the negative tells us it's reflected across the x. The 3 tells us the stretch or shrink. Since 3 is greater than 1, it's a vertical stretch. Does that make sense? It might be tempting to think of it as negative 3 for the vertical stretch or shrink. We're just looking at the 3. The negative is reflection. 3 tells us about the stretch or shrink. We don't look at them together. Questions on this here? Again, we have 2 transformations. We have parentheses 1/4 x, close parentheses squared, minus 2. Let's down 2. Let's do the nice one first. Down 2. 1/4 is being multiplied by our x inside the parentheses. Yes, we're talking about horizontal stretch or shrink. Now, before we even start determining if it's a stretch or shrink, we flip it. So 4 over 1, or 1 over 4 becomes 4 over 1, which is just 4, yes? So it is horizontal. Stretch of 4. Because once we flipped it, we're not looking at the 1/4, it's really just 4. It would be stretched because that number is greater than 1. Yes? Which means that as this graph here is going to open more to the left and right, we're stretching it horizontally. It's going to increase faster along the x-axis. And it's also going to move down too. So if we looked at this here, 4 equals enter, 1 over 4. I need that extra set of parentheses graph. It didn't move it down to, I was just looking at the stretch, horizontal stretch. We can see that it did increase along the x-axis faster, yes? That's why we have 1/4 as a horizontal stretch. Questions on this here? So really when we have a value in place for the horizontal stretch or shrink, before we even try to figure out which, take it, flip it, see what that is. If that value is greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink horizontally. Questions on this here? No. Yes, I would agree with that. So there's not always more than one. There can be. There also doesn't have to be. So here, we only have one thing being applied to it. There is no negative in front of the parentheses or in front of the x inside. So there's no reflection. Nothing being added, subtracted to it. So there is no up, down. There is no left, right. The only thing we have is the 1/3 being multiplied by x inside the parentheses, which means we're talking about horizontal stretch or shrink. But before we even look at that, we take that 1/3 and flip it. If we flip 1/3, it becomes 3 or 1 or just 3. Is this 3 greater than 1 or between 0 and 1? It's greater, so this would be a horizontal stretch of 3. That's it. Questions on this here? This one we do have two transformations. We have the multiplication of 3 and the x minus 1. We can do the x minus 1 first. X minus 1 tells us we're moving it to the left or to the right. And the 3, the multiplication of 3 is our vertical stretch or shrink. And it would be vertical stretch of 3. Since the 3 is greater than 1, it's a vertical stretch. If it had been between 0 and 1, it would be a vertical shrink. Questions on this here? So let's see what we have here. Here we actually have 3. So let's just start with the negative. Since there's a negative outside the parentheses, we're talking about a reflection. Across the x-axis. If it's inside the parentheses in front of the x, it's across the y-axis. So we have that one taken care of. Since we have plus 3 inside's left or right, and it would be left 3. And lastly, we have plus 2, which is up 2. So it's across the x-axis, reflected across the x-axis, left 3 and up 2. That's it. Questions on this here? We'll finish up the last of these tomorrow applying these transformations, but your homework for this here is 3 through 11 odd, 17 through 21 odd, and 27 through 29 all.
Yes, all.
So the only ones that we're doing odd are 3 through 11 and 17 through 21. 27 through 29 is all. And on all these here, you're just describing the transformation. You do not have to graph it.